Hello and welcome everyone to Infinity Learn by Sri Chaitanya, and I'm Ravindram, and today I'll be discussing the physics portion of the weekend test 1-5. Okay, so let's begin with the first question. Okay, so in this question, as you can see, they have asked us to find out the charge stored in the second capacitor, right? And in the first capacitor, they haven't given any information about the charge, but they have given us the total energy stored in the first capacitor, right? Now, what is given the total energy? Now, acha, one more thing is what is common right now in between these two capacitors? You can say, so the potential drop between these two capacitors is same right now. Okay, so if I say what is the energy stored in one capacitor, you will say, sir, half C1 into V square. Energy stored in the second capacitor will be half C2 into V square, right? So from here we can get the ratio of the energies stored. So U1 by U2 will be equal to C1 by C2, that is 2 upon 4, which is 1 by 2, right? So what is U2 here? 2 U1, and what is U1? 16. So it is 32 microjoules. Now 32 microjoules is the amount of energy that is stored in the second capacitor, but we don't want the total amount of energy. What we need is the total amount of charge that is residing on the second capacitor, right? So what we will do, we will say that U2 is equals to Q2 square by 2C2. Am I correct? Now what is C2? 4 to the 8. 8 into U2, that is 32 into 8 is equals to Q2 square. So 32 into 8 is how much? 256 is equals to Q2 square. So what is Q2? It is 16 micro coulombs. Got it? So second option is correct. So this is how we are going to approach the first question. Now let's move on to the second question. Plates of a parallel plate capacitor are connected to the terminals of a battery. If the separation between the plates is doubled, see, whenever a capacitor is connected to a battery, that means one thing, that the potential difference across the capacitor will remain constant no matter what. Why? Because the battery is a device which maintains constant potential difference across its terminals, and since this capacitor or the plates of this capacitor are connected to the ends or terminals of this battery, so they are also going to maintain the same amount of potential difference as the battery is maintaining. Correct? Now what is electric field? Electric field is potential difference upon the distance between the plates, right? If electric field is constant, then definitely we can use this formula. Now what they are saying is, if distance is doubled, right? If distance or separation is doubled, but the potential difference is not going to change, so we can say that electric field is inversely proportional to D. So if you are going to double the distance, electric field will definitely become half. Okay, so which option is correct, my dear students? Second option is correct. So we'll move on to the third question now. Now this is a wonderful question, and I need you to understand how to approach these kind of questions. Why? Because these kind of problems are very common in NEET. So if there's a possibility of question coming from capacitor or this particular chapter, then there's a high probability that this kind of variety is going to come in examination, right? So we are going to solve this question very carefully, right? So let's read the question first of all, analyze the data, and then see how we can use the data to solve it. So to form a composite 16 microfarad and 1000 volts, so we want an equivalent capacitance of 16 microfarad, and the overall potential drop across these capacitors will be 1000 volts. Now, one single capacitor is 8 microfarad that is available to us, and the potential drop across this single capacitor is 250 volts. Okay, now that is awesome. So what we will do, we want a potential drop of 1000 volts. Am I correct? Right, we want a potential drop of 1000 volts. So technically we want 1 2 3 4, right? That means we want 250 volts drop here, 250 volts drop here, 250 volts here, and 250 volts here. That means we need equal number of capacitors between these two terminals, AB, then CD, then EF, and GH. Is it cool? Now how we will approach it, let's quickly see. So let's say we are putting n capacitors here in parallel, because the drop across one capacitor will be 250 volts. So we will put n capacitors in parallel like this. Okay, how many capacitors? N. Here also we will put n. Here also we will put n symmetrically. Here also we will put n in parallel, right? So suppose this capacitance is C. So what is the capacitance here of between these two terminals? So you will say that overall NC is here, right? Here NC capacitance, because when capacitors are connected in parallel, we add the overall capacitance to get the equivalent capacitance, right? NC here and NC here. Now what is the overall equivalent capacitance? You will say, sir, since NC, 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 NC are connected in series 4 times, so the overall capacitance will be NC by 4, right? Now what is C equivalent we desire? 16. And what is C that is given? 8 upon 4. So tell me, 4 ones are 4, 2s are 2, ones are 2, 8s are. That means n is equals to 8. So we need to put 8 capacitors in parallel, right? In parallel in every section. And how many sections are there? 4 sections are there. So total number of capacitors that we need is n into 4. That is 32 capacitors we need. So which option is correct? Second option is correct. Are you understanding? Okay, in case you're not able to understand, in case you have any doubt, you can rewind the video and see if you're not live. Okay, and if you're watching the recording, then definitely you can rewind the video and see the solution once again. Okay, now one more thing I would like to tell you, students, if you're watching the recording of this video, then what you do is, whenever I start giving the solution of any question, you pause the video and try the question on your own. Okay, try the question on your own, and when I give you the solution, right, then find out what was your mistake, or even if your question was right, then what was your method, and did you learn anything new from my method, or our methods are same. Okay, so you need to deeply analyze every question and solution, then only you're going to learn from this, otherwise not. Okay, otherwise nothing is going to help you in examination. So let's move ahead. Fourth question, they are saying a parallel plate capacitor is connected across a battery. Now keeping the battery, again the term battery, whenever it comes, battery comes, that means the potential difference across its terminals will remain constant no matter what. So V is going to remain constant. That is our first condition as soon as you read the word battery. Now keeping the battery connected, a dielectric slab is inserted. Absolutely. So what is happening here? A dielectric is being connected, is being inserted, and this battery is already connected. So it is going to maintain this common potential here. So if initially the capacitance was C epsilon naught A by D, we already know that new capacitance will be K epsilon naught A by D. So C dash will be equal to KC. So capacitance will be K times C. Do you understand this? Yes. Okay, now the capacitance is going to increase, right? So see, simple question. Q is equals to C into V. So if V is constant, Q is directly proportional to C. So Q dash will be equal to KC into V. That means Q dash will be equals to K times Q. That means charge increases. So initially if the charge was Q in the capacitor, and after insertion of the dielectric, the capacitance becomes Kc and the charge becomes Kq and minus Kq. That means battery has to supply an extra amount of charge. How much is that? K minus 1 into Q. Are you understanding? So if battery has to supply extra charge, then work done by the battery will be there. Delta Q into V. Are you understanding? So this is the whole concept of this particular question. Now what they are asking is, no work is done? Not possible. Work is done by the battery and energy stored increases. Obviously, see, what is energy stored initially? Initially energy stored was half C V square. Now V is remaining constant, but C becomes Kc. So half Kc V square, that means the total energy becomes K times, right? So overall energy K times, that means energy increases. So work is done by the battery, and exactly the work done by the battery goes in two places. One is increasing the energy of the capacitor, and second is in the heat, in the resistance in the connecting wires. Okay, in the form of heat in the resistance in the connecting wires. Did you get it? Okay, so obviously second option is correct. If second is correct, you don't need to go for third and fourth option. If you have time, you can read and verify that they are also incorrect, right? So let's move on. Question number 5. This is simple one. The work done in increasing the potential of capacitor from V volt to 2V volts. Okay, so V1 is V and V2 is 2V. Then the work done, see, work done is change in potential energy of the capacitor, right? half C into V2 square minus V1 square. So it's going to be half C into 2V whole square minus V square. That is going to be 3CV square by 2. 3CV square by 2. That is what work done, right? So we can say that W is equals to 3 by 2 CV square, right? Now what they are asking is, what is the work done if the potential changes from 2V volts to 2 volts to 4 volts, right? 2 volts to 4 volts. Acha, like this, okay? So it is going to be half C into 16 minus 4, that is 12. So it is going to be 6 CV square. Do you understand? It is going to be 6 CV square. Now what do they need? Now what is CV square? CV square is 2 by 3 W. We can write it like this. W2 is 6 into 2 by 3 into W. So 3 ones are 3 twos are. Answer is 4W. Got it? Now sixth question. Sixth question says that two capacitors of capacity 4 and 6 microfarad are connected in series and in batteries connected to the combination, right? So they are connected in series 4 and 6, right? 4 microfarad and 6 microfarad. And this combination is connected to a battery. Yes, no problem. This combination is connected to a battery. The energy stored is E1. If they are connected in parallel and if the same battery is connected to this combination, then the energy stored is E2. Okay, fantastic. So two capacitors of capacity 4 and 6 are connected in series and a battery is connected to the combination. See, initially energy will be half into when they are in series. So what is equivalent capacitance? See, energy will be half into C equivalent into V square, right? We are going to use this formula. Half into C equivalent into V square. Now when they are in series, what is C equivalent? C1 C2 upon, and when they are in parallel, then, right? Now if you want, you can take the ratio. E1 upon E2 will be C1 C2 upon C1 plus C2 into C1 plus C2, right? Got it? So it will be how much? It will be E1 by E2 is equals to C1 C2 is what? 4 into 6 upon 4 plus 6 whole square. Got it? So you can get the answer from here, right? Now solve it, get your answer. Okay, 4 6 are 4 25 are. So 6 into 26 is to 25. Seventh question. The force acting upon a charged particle kept between. See, simple logic. Whenever you use a capacitor, there are two plates. One has charge plus Q, another has charge minus Q. So the electric field in between is due to both the plates, right? So electric field E is actually equal to Q by 2A epsilon naught plus Q by 2A epsilon naught. Both are in same direction. Why? Because of the positive plate, the field will be in this direction. Because of the negative plate, also the field will be in the forward direction, right? So we will add up these components or these fields and we will say Q by A epsilon naught is the total field inside. So what is the force acting on another charge which is kept there? F is equals to Q into E. Now, if you remove one plate, then automatically electric field becomes half. So technically force also becomes half. So which option is correct? Fourth option. A parallel plate capacitor is made by stacking n equally spaced. Okay, so that means this is one capacitor, two, three, like these plates are there. Can you see that? So how many plates are there? There are n plates. Now you tell me, if I arrange two plates, how many capacitors I get? One. If I arrange three plates, how many capacitors I get? Two. That means if I arrange n plates, how many capacitors am I getting? I am getting n minus 1 capacitors. Now how they are connected? Alternatively. They are saying alternatively. That means this is connected to point terminal A, then this is connected, then this is connected, and this is connected to point terminal B, then this is connected like this. Okay, so what is happening? So across every capacitor or across every plate, I can say 1 and 2, the potential drop is VA minus VB, that is V. So potential drop across every capacitor plate is same. That means they all are in parallel, and when they are in parallel, so what is the equivalent capacitance? Total number of capacitors multiplied by capacitance of a single capacitor. Got it? So answer is fourth option, N minus 1 into C. Ninth question. In the circuit shown in the figure, the potential difference across 4.5 microfarad is, okay, first of all, let's find out. See, if this is 4.5 microfarad, which is C1, and they are in parallel, 3 and 6 are in parallel. So if they are in parallel, what is the equivalent of them? You will say, sir, C2 will be 9 microfarad. Now, carefully we will solve this and we will build a logic now. What is that logic? We have a battery here, right? We have a battery here. How much it is? 12 volts, suppose. Now, the charge on both these capacitors will be same as they are in series. Now, you will say, sir, Q is equals to C into V, and if charge is same, on both the capacitors, then the potential drop is inversely proportional to capacitance. Yes or no? The potential drop will be inversely proportional to capacitance. Why? Because charge on both the capacitors is same. Yes. So what will you do? You will say that if Q is same, that means CV is constant. That means C1 V1 is equals to C2 V2, right? So we can say that V1 is equals to C2 upon C1 plus C2 into V, and V2 is equals to C1 upon C1 plus C2 into V. Do you understand this thing? So what is the ratio? Okay, or either you do this, or what you can do is you can say like this. See, that since V is inversely proportional to C, and what is C1 is to C2? C1 is to C2 is 4.5 upon 9, that is 1 is to 2. So we can say V1 is to V2 will be just opposite of its 2 is to 1. So what is V1? So V1 will be 2 upon 2 plus 1 into V. So what is V1? 2 by 3 into 12. That is how much? 8 volts. Do you understand this logic? This is pretty simple one. So whenever capacitors are connected in series, the charge on each capacitor will be same. So the potential drops will be in the inverse ratio of their capacitances. So if capacitances are in the ratio C1 is to C2, potential drop will be in the ratio V2 is to V1. Right? Is it clear? Yes or no? And if even after this, if you don't want to go with this method, you want to go with the absolutely natural method. Suppose you don't want to do any of this stuff. You want to say, no, sir, we will go with the absolute natural method. So what is natural method? See, you will say, sir, this is 4.5 microfarad. This is 9 microfarad, right? This is 12 volts. What do you need? You need the potential drop here. So you will say, what is C equivalent? First, you need to find out C equivalent. Yes or no? So you will say, sir, 1 by C equivalent is equals to 1 by 4.5 plus 1 by 9. So it will be 2 plus 1 by 9. That is 3 by 9. That is 1 by 3. So C equivalent will be equal to 3, right? 3 microfarad. Now what is the charge? Let's find out the overall charge. Overall charge will be equal to C equivalent into V. What is C equivalent? 3 microfarad into V is what? 12 volts. So how much will this be? 36 microcoulombs. Now you know the charge. Now you will say, sir, Q is equals to C1 V1. So what is V1? It is Q upon C1. Now what is Q? 36 microcoulombs upon what is C1? 4.5 microfarad. So answer will be 8 volts. Either you can go with this normal method, otherwise you can use the concept of taking ratios. Okay, so I have told you both the methods. Whichever you feel like, you can go for that method, right? So this is the absolutely what you say conventional method, step by step. Now, question number 10, what they are saying, the capacity of a parallel plate capacitor is 10 microfarad when the distance between the plates is 8 centimeter. If the distance is reduced to 4 centimeter, the capacity will be simple. What is capacitance? Epsilon naught A by D. So, if you say that distance is reduced to half its value, D by 2, because it was 8 initially, now it is 4. So, it is 2 times epsilon naught A by D. So, it is 2 times C. Got it? So, capacitance will be doubled. 11th question. A 10 microfarad capacitor is charged to a potential difference of 50 volts. See, whenever two capacitors are connected, remember the common potential is C1 V1 plus C2 V2 upon C1 plus C2, right? So what they have done is they have charged one capacitor and connected it to another uncharged capacitor. So V2 is 0, V1 is 50 volts, and they have given the information of C1 and C2 also, right? So what is V? C1 V1 plus C2 V2 upon C1 plus C2, right? So common potential is 20. It is 10 into 50 plus 0 upon 10 plus C, right? So it will be, so 10 plus C will be 25. So what is C? 15 microfarad. Got it? Any doubt? No. So question number 12. Now this is an interesting one. Let's say this is capacitance C and this will be Kc. Yes or no? So what is C1? They haven't given anything. Now we will use that logic again. What is the ratio of the capacitances? The ratio of the capacitances C1 is to C2 is C upon Kc. Let's say here the drops are V1, V2 and the capacitance are C1, C2, right? So it is 1 upon K, which is 1 upon 3. So what is V1 by V2? You will say that 3 is to 1. So what is V1? 3 upon 3 plus 1 into 10 volts. So what is V1? 3 by 4 into 10. That is 7.5 volts. So what is V2? Automatically 2.5 volts. Isn't it wonderful? This method is useful or not? Right? So you can go with this option. Question number 3, they all are in parallel. Now you will ask me, sir, how do you know? See, if this is A, so this complete wire has the same potential A. So this is also A. And if this is B, so this complete wire has the same potential B. Now let's draw A and let's draw B. From A, see, so from A, how many plates are attached? So you will say, sir, this capacitor's plate, this is attached to A, and this is also attached to A, and this is also attached to A. And how many plates are attached to B? 1, 2, and 3. These are all attached to B. So don't you think they all are in parallel? C, 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 and in parallel, what is C equivalent? 3C, 9 microfarad. Got it? Now here, oh brilliant. Effective capacitance, see, 3 and 6 in series. See, one thing I want to tell you students, suppose whenever capacitances are in parallel, one is C, other one is 2C. So remember the answer is 2C by 3. And if there are C and C, then the answer is C by 2. Remember, if C and 2C are there, then in parallel it will be, sorry, I'm so sorry, not parallel, series. That was for resistance, series. If C and 2C are given, then C equivalent is 2C by 3. And if C and C are given, then C equivalent will be C by 2. Got it? So we will use this logic. So for 3 and 6, what is the answer? For 3 and 6, they are in series. So answer will be 6 by 2. 6 by 3. 6 by 3, that is what? 2 microfarad. So you will say 2 microfarad, right? And what about 2 and 2? 2 and 2 will be 2 by 2, that is 1. 1 microfarad. Now 2 and 1 in parallel, they will add. So C equivalent will be 3 microfarad. Got it? So which option is correct? First option is correct. Now let's go to question number 15. If the charge on a body is increased by an amount of 2 coulombs, the energy stored in it increases by 21%. The original charge of the body will be very simple. What is energy? Q square by 2C. Now they are increasing the charge by 2 coulombs, and they are saying that this time it is 21% increases. So how much it is? If it increases 21%, that means it is 100 plus 21, sorry, 100 plus 21 upon 100 fraction wise into q square by 2c. So if you see, you will say, sir, q plus 2 whole square is 1.21 into q square, right? So q plus 2 will be 1.1 into q, because under root 1.21 will be 1.1. So q will be, sorry, so 2 will be equal to 0.1 q, and from there you will say q is 2 upon 0.1, that is 20 coulombs. Got it? Now question number 16. The ratio of the, oh god, we all know that in the hydrogen atomic model, the kinetic energy is this, the total energy is this, the potential energy is this. This is kinetic energy, this is total energy, this is potential energy. Now there's a relationship. Kinetic energy is minus of total energy, and potential energy is 2 times of total energy, right? So you have to utilize these relationships. So which one is asked? What they are asking? The ratio of the kinetic energy to total energy. That means the first relationship they are asking, not the second one, right? So what is kinetic energy upon total energy? It is gonna be 1 is to minus 1. Second option is correct. Got it? Okay. Now, when alpha particle of mass m moves with a velocity v, bombards a heavy nucleus of, okay, its distance of closest approach will be, see, whatever its kinetic energy will be completely converted into its potential energy, right? So overall kinetic energy is completely converted into potential energy. So obviously R is inversely proportional to M, as other factors are constant. V square is constant because it is the initial velocity that is already given. So the 2 is constant, V is constant, K, Z, E, all these are constant. So R is inversely proportional to M, right? 18. Okay, longest wavelength means least energy transition. Longest wavelength, always remember. So whenever they're asking for longest wavelength means lambda max, that means they're asking for least energy, minimum energy transition. Do you understand this? Yes. Now, suppose I talk about Lyman series, Balmer series, Bastian series. So for Lyman series, the transition is this, least energy transition, and for Balmer series this is the least energy transition, n equals to 1, n equals to 2, n equals to 3. So for Lyman series the transition will happen from 2 to 1, and for Balmer series it will happen from 3 to 2. So you will say 1 by lambda 1 for the Lyman series. It will be Rydberg constant, you know the formula, Rydberg constant into 1 by 1 square minus 1 by 2 square. And for Balmer series it will be Rydberg constant into 1 by 2 square minus 1 by 3 square. It will be how much? 3 by 4 r, right? It will be how much? 5 r by 3 3 is 9 to 4 9 is 36. Now if you take the ratio, what you want is lambda 1 by lambda 2. So you will say lambda 1 upon lambda 2 will be 5r by 36 into 3r by 4. R and R gets cancelled, and 4 ones are 4 nines are 9 threes are 27. 5 is to 27. Which option is correct? Second option is correct. 19th question. The first Bohr radius of hydrogen atom is R. The second Bohr radius of helium will be C. Radius is 0.53 into n square by z angstroms, right? So if I talk about hydrogen, then it will be 0.53 into 1 square by 1 angstroms. And if I talk about helium, it will be 0.53 into, we are talking about the second orbit, upon Z is 2 angstroms. That means 2 times 0.53 angstrom. That means if this is equal to capital R, it will be equal to 2R. Get it? So third option is correct. Now coming to question number 20. See, we know that angular momentum is mvr equals to nh upon 2 pi. So if it is 3h upon 2 pi, that means n is equals to 3. They are talking about the third orbit of the third shell. Then the energy of the electron, what is the formula? Minus 13.6 into z square by n square electron volts. Z is 1 because it is hydrogen, as they have mentioned already, into, that is 1 square by n is what? 3, that is 9 electron volts. So obviously 1.511. So answer is minus 1.511 electron volts. Do you understand this? Now let's move on to question number 21. Okay, we all know that x, a, z. A minus z is the number of neutrons. Okay, and z is the number of protons. Right? So I guess you can do the calculations. Second option will be correct. Now what they are saying is this. Achha, there's a relationship, students, that average radius of the nucleus is r naught a to the power 1 by 3. A is atom mass number, right? So for aluminium, they are saying R1 is equals to R naught into 27 to the power 1 by 3. So obviously for beryllium, they will be say R naught into 125 to the power 1 by 3. Now if you take the ratio, R2 by R1 will become 5 is to 3, and from there R2 will be 5 by 3 times R1 or 5 by 3 times radius of aluminium. Do you get it? So this simple formula that is given on the very first page of your chapter, remember this because this is important. Now the second one is also associated with this. The density of the nucleus is almost constant. Remember this. For every nucleus, it comes out to be 3 into 10 to the power 17 kg per meter cube. Even remember this data. It has been asked in like previous 2020 paper or 2019. I can't recall. But this question has been asked where they are saying, where they are asking, they have given 4 options, and they are asking what is the density of nucleus. Density of nucleus. They have given options like this. So what? Third option is correct. So this type of question has also been asked, right? So be prepared. So it does not depend upon atomic mass number. Does not depend, as it is constant. Does not depend, as it is constant. Now question number 24. The mass defect for the, okay fine, mass defect is already given. So what is binding energy? Binding energy is mass defect into c square. We can express, if delta m is given in terms of atomic mass unit, so we can say it like this: 0.0303 into 931.5 mega electron volts. This will be energy, right? Okay, per atomic mass unit. Per nucleon, they are asking binding energy per nucleon. So upon helium, for helium, what is A? 4. So do the calculation, exactly answer will be, so binding energy per nucleon for helium will come out to be 7.002 something mega electron volts. So second option is correct. Got it? See, what we do is sometimes delta m into c square, we can say that c square is equals to 931.5 mega electron volt per atomic mass unit, right? So we replaced c square with this value and got the answer, because anyways delta m was given in atomic mass units. Are you getting the idea? Now, for a radioactive material, the half-life is 10 minutes. Okay. Half-life, that means T half is 10 minutes. What they are asking is, if initially there are 600 number of nuclei, how many nuclei are there? 600 number of nuclei. So what is N naught? N naught is 600. if 450 have been disintegrated, then how many are remaining? 150 nuclei are actually remaining right now. Okay, and the formula is n is equals to n naught upon 2 to the power small n, where small n is actually the number of half lives that have been that have happened, right? So it is 150. This is 600 upon 2 to the power n. 150 ones are 4s are 2 to the power n will be 4 and n will be equal to 2. That means how many half lives have been passed? So you will say, sir, 2 half lives. What is 1 half life? 10 minutes. So 2 half life will be 20 minutes. So what is the correct answer? 20 minutes for this particular question. Okay, students. I am pretty much confident that you are understanding each and every discussion, each and every point. Okay. And in case you have any doubt, you can surely put your doubts in the comment section below, and I will definitely respond to your doubts in that. Okay. Question number 26. The half-life of a radioactive isotope X is 20 years. Again, the same question on half-life. It is how much? 20 years. That means its concentration becomes half in 20 years. It decays into Y, and the two elements X and Y were found to be in the ratio 1:7. Right. See, if this was initially N naught, right? So finally it is N. So how much it is? N naught minus N. Are you able to understand? Initially this is the case. After some time they are saying like this has happened, right? Now they are saying that their concentration N upon N naught minus N is 1:7. They have mentioned. Are you understanding? So it will be 7N is equals to N naught minus N. 8N is equals to N naught. So the remaining concentration will be N naught by 8. Do you understand? Now we have the formula. Current concentration is N naught upon 2 to the power N, or N is the number of half-lives. So we can compare N naught by 8. So we will say 2 to the power N is equals to 8. 2 to the power N is equals to 2 to the power 3. So N is equals to 3. That means total time is 3 half-lives. Now 3 half-lives means 1 half-life is 20 years. So 3 half-lives means 60 years. Do you understand? So that this is the average age of this rock. Sorry, this is the overall estimated age of the rock, 60 years. Do you understand this? Clear? Every step. See, initially the concentration of X is N naught, Y is 0, because X has not even started disintegrating. Once it starts disintegrating, the concentration that is left is N, right? And the concentration that has disintegrated will be N naught minus N also, obviously. So whenever we apply this formula, students, remember that N is the concentration which is remaining, not the concentration which has been disintegrated. Clear? Now question number 27. This is also again based on the concept of half-life. Samples of two radioactive nuclides X and Y each have equal activity. Now we know this formula. A is equals to A naught e to the power minus lambda T. And we also know that T half is equals to ln2 by lambda. Right? This is known to us. Right? So what is lambda? It is ln2 upon T half. Clear? So what they are asking is this. One sample, so initially both have same activity. That means A naught is same for both of them. So A1 upon A2 after 48 years, right? So we will say that it is A naught e to the power minus ln2 upon what is T half for the first 24 years into T is how much? 48 upon A naught e to the power minus ln2 upon what is the half-life? 16 into how many years? 48. Do you understand? So we will say 24 ones are 24 twos are 16 ones are 16 threes are. So we can say that A1 by A2 will become e to the power minus 2 ln2 upon e to the power minus 3 ln2. Now these coefficients will become power inside, right? So e to the power minus ln4 upon e to the power minus ln8. So minus power means reciprocal, so we will say e to the power ln 8 upon e to the power ln 4. This is what 8 upon 4, right? So a1 upon a2 will become 8 by 4, that is 2 is to 1, or ultimately 2. You know this thing. Let me tell you that e to the power ln x is always equal to x. And suppose I say 2 ln x, so this will be what? Ln x to the power 2. Or I say a times ln x, so this a will become the power. You understand this thing? Same concept we have applied here. Okay, so 2 ln 2 means it is ln 2 to the power 2. 3 ln 2 means ln 2 to the power 3. That is why I said it is minus ln 4 and minus ln 8 here. Got it? So this was a little interesting question in terms of the calculation. Otherwise this was a simple one. The 28. We already know what is the formula of acceleration in the pulley: m1 minus m2 upon m1 plus m2 into g. Put the values, get the answer. Okay. Now this is interesting. See, suppose they have given a rope here and they are saying that this rope is being pulled with a force F, right? Let's say the overall length of the rope is capital L, and what is the tension of the rope at a distance small l from the end where the force is being applied. Okay. So what is this length? It is capital L minus L. Now what we will do is we will divide this complete rope into two masses. And this, the imaginary rope that I have connected here, this is massless. So if you are applying force F, so automatically this is m1 and this is m2. So automatically they are moving with the same acceleration A. And we need to find out this tension T. Right. So if we overall consider about this system, this total forces F on this system is equals to total mass into total acceleration. So what is acceleration? F by m. Now what is the tension in this imaginary rope that I have taken? See, it is m1, so tension is T, and this time the acceleration is being provided by this particular tension which is applied by the rope that I have imagined here, right? So T will be equals to m1 into A. So how we will find out the value of m1? What is m1? M1 is, what is m1? M1 is total mass per unit length into length of the element into A. And what is A? F by capital M. So what is the tension? It will be F into 1 minus small l by capital L. So which option is correct? First option is correct. Do you understand this? A player caught a cricket ball. Okay, simple. The average force is change in momentum upon time taken. Finally, he's going to stop the ball, so final momentum will be 0, right? So 0 minus initially is 150 grams converted into kg. Velocity is 20 upon what is the time taken? 0.1. Okay, so the average force will become minus 150 into 20 upon 1000 into 0.1, that is 100. So this is all gonna get cancelled here and the answer will become minus 30 Newton. Do you understand? Yes or no? Yes, perfectly yes. Write in the chat box also. Okay, students. So if one more thing, if you have any other method for any question, you can explain that method in the chats also. Okay, so in the comment section, if you have any other method, you can explain that method in the comment section. I will definitely love to read all those comments, right? So it will be a hell lot of a discussion between us. So is it understood? Now question number 31, it is exactly similar to question number 29. Okay, so here they have already divided and they have said that it is 2 kg and this is 1 kg. So first of all, we will say overall this system will go with acceleration A and the net force that is acting on the system is 3 Newton. So 3 is equals to total mass into acceleration. So acceleration is 1 meter per second square. Now what about this force F? You take the mass 1 kg and What force is acting? F. This is the reaction force between them. What is the acceleration? A. So what is F is equals to ma. What is m1? What is a1? What is the answer? 1 Newton. Do you understand? Now let's come to question number 32. It's very simple and it's a very common question. If you're launching it with P, this is theta. So it will have two components. One will be P cos theta and another one will be P sin theta upwards. Now once it lands on the ground, again the momentum will remain same magnitude wise. The angle will also remain same. So this will be P cos theta and this will be minus P sin theta because it is downwards. So when you are asked to find out the change in momentum, so obviously you can say horizontally there is no change, yes or no? P cos theta and P cos theta horizontally it is not changing, but it is changing only in the vertical direction. How much is that? Final momentum minus initial momentum. So answer will be minus 2p sin theta, or magnitude wise you can say 2p sin theta, right? Because in the horizontal direction the velocity remains constant and hence we can say the momentum also remains constant in the horizontal direction. So the momentum is changing only in the vertical direction. Is it okay? Question number 33. A man of mass 60 kg is riding in a lift. Okay, we already know. What is the formula for normal in such cases? M into G plus A if the lift is going up with acceleration A, and normal will be M into G minus A if the lift is going down with acceleration A. Do you understand? Put the values, get your answer. 34. This is also pretty simple. So a body of mass 0.25 kg is projected with a muscle velocity of, okay, with a muscle velocity of 100 meter per second. Let's say this is V1. Let's say this is M1. And this is the tank which is going back with velocity V2 and its mass is M2. So obviously momentum conservation, we will say M1 V1 minus M2 V2. Why? Because V2 is negative, definitely. Must be equal to initial momentum 0 plus 0. So M1 V1 is equals to M2 V2. Now put the values, get your answer, right? A bomb at rest explodes. Again, see, initially it is at rest, so overall momentum is 0. Now what is final momentum? So final momentum, you will say it will be minus 2p I cap plus p j cap plus, what is the third momentum? Let's say p naught. P naught, we don't know direction, so let's say vector p naught, right? Now initial and final momentum will be 0, yes or no? So you will say, sir, initial and final momentum will be equal, and initial momentum is 0, so final momentum will be a null vector, right? So minus 2p I cap plus p j cap plus vector p naught must be 0. So vector p naught will be equal to 2p I cap minus p j cap, right? So we will say that p naught square is equals to 2p whole square plus p whole square under root, that is, sorry, okay, write this. So what is p naught? P naught is root 5p. Got it? So which option is correct? Third option is correct. 36. This is an interesting question. Again, same kind of question. You remember? Now here we will use a beautiful logic. See, first of all, this 10 and 10 in series, so will become 10 by 2. That is 5. Yes or no? 10 by 2, 5. And then 5 and this 10 in parallel will become 15. So if you find out properly, you will say, sir, this is 5 microfarad and this is 15 microfarad. This is A, this is B, this is C. Now here the drop is V1, here the drop is V2. Again we know that this is C1 and this is C2. So what is C1 upon C2? You will say, sir, 5 by 15, that is 1:3. So what is V1 upon V2? 3:1. So what is V1? 3 upon 3 plus 1 into overall drop is what? Here the potential is 2000 volts and here the potential is 0 volts because it is earthed. So into 2000, right? So it is 3/4 of 2000, that is 1500 volts. So 1500 volts is actually the drop. What is 1500? VA minus VB is 1500. Please don't get confused. VB is not 1500. VA minus VB is 1500. So what is VB? VA minus 1500, that is 500 volts. Because the very first option they have given 1500, which is wrong. And any student who does not pay attention to its solution or does not pay attention to the question properly might take the first option absolutely in its first attempt. Right? So don't make that kind of a mistake here, because you are not permitted to make these mistakes in examinations, because you know the concept, you're doing everything correct, but just because of this silly mistake you're losing your marks. Now question number 37. A capacitor of capacitance 3 microfarad is charged to a potential of 6 volts. Now the charging battery is removed and the capacitor is connected in parallel with another capacitor. Again, simple, we know that. What is the loss of energy in such cases? Half C1 C2 upon C1 plus C2 into V1 minus V2 whole square. Now every information is given. What is C1? C1 is 3. C2 is 9 upon 3 plus 9 into 6 minus 0 whole square, because the second one is uncharged, right? Now you solve it and your answer will be 40.5 microjoules. Clear? Now here again we will use the logic of point potential technique. See, this is point A, so this is A, so this is A, this is also A, and if this is B, then this is B and this is B. But this point is absolutely new, this is C, because it is either connected to A or not connected to B, right? So we will say this is A, this is B, and somewhere it is C, right? So how many capacitors are there directly between A and B? You will say, sir, 1. So this is a capacitor directly between A and B, 2 microfarad. How many capacitors are there between A and C? You will say, sir, there are 2. A and C, A and C. So there are 2 capacitance between A and C. Right. Now how many capacitors are there between C and B? You will say, sir, 1. Now I guess you can solve it. This is 2 microfarad, 2 microfarad, 2 microfarad, and this is already 2 microfarad. Got it? So what will you do? These 2 and 2 in parallel will become 4, right? Yes or no? 2 and 2 in parallel will become 4. 4 and 2 in series will become 4 by 3. Acha, capacitors values are different or what? 1 minute. Acha, this is 12. This is 12. I'm so sorry. We need to check. This is 12. Okay, now 2 and 2 in parallel will become 4. Okay, 2 and 2 in parallel will become 4. 4 and 12 in series we have to find out now. So we can do it, I guess. Okay, so 1 by 4 plus 1 by 12. So it is how much? This is gonna be 1 by 3. So what is C equivalent? C equivalent is 3 microfarad for the upper layer. For the upper layer. So you will say ultimately it is 3 upwards and 2 downwards. Now they are in parallel again. So finally what is C equivalent? 5 microfarad. Got it? This is the C equivalent of the upper branch. I'm talking about this upper branch. Clear? Now question number 39. This is an interesting question. I can say this is the best question of the paper. Okay. So there are 2 plates. Already there is some distance D. Now, a dielectric is inserted in between having some thickness. How much is the thickness? 2 mm. This thickness is 2 millimeter, right? Now, so obviously capacitance will change, but in order to attain the previous actual capacitance, we need to produce a little difference here. What we need to do is we need to shift this plate by an extra distance of 1.6 millimeter, right? Okay, cool. So what we will do, we will say initially there was a single capacitor whose capacitance was epsilon naught A by D. Now, To achieve the same, now there are two capacitors actually, one with the dielectric, another without the dielectric. Okay, so let's say this is C1, this is C2. Now what is C1? Let's write down. It will be epsilon naught A upon, what is the overall width now? Overall gap, D plus 1.6 minus 2. What is the overall gap? D plus 1.6 minus 2. That is D minus 0.4. Yes or no? So now the gap is D minus 0.4. And what is C2? C2 is K epsilon naught. K epsilon naught A upon, area is not changing, upon 2 mm, right? So this information is available to us. Now they are in series, right? And they are saying that overall capacitance is not changing. So 1 by C must be equal to 1 by C1 plus 1 by C2. So epsilon naught A by D is equals to epsilon naught A by D minus 0.4 plus K epsilon naught A by 2, right? So what we will do, we will say epsilon naught A will get cancelled. It will be D equals to D minus 0.4 plus 2 by K. Now D and D are gonna get cancelled. So 0.4 is equals to 2 by K. So K will be 2 upon 0.4, that is 20 upon 4, that is 5. So which option is correct? First option is correct. Clear? See, overall gap was D. Then they placed a 2 mm. Then they placed a 2 mm dielectric. So what is the gap left? D minus 2. But they have increased it by 1.6. So what is the gap now remaining? D minus 2 plus 1.6. So that is D minus 0.4. Are you understanding? So what is the gap where there is no dielectric? It is overall D minus 0.4. Now question number 40. See, what is the capacitance of a sphere? 4 pi epsilon naught r. Right. Now there are 64 drops. Volume of each is 4 by 3 pi r cube. So overall volume for the new drop will be 4 by 3 pi r dash cube. So r dash will be, from here you can say 4r. So obviously C dash by C will be R dash by R from this formula. So it is 4R by R. It is 4:1. Got it? 41. An electron revolve around the nucleus of hydrogen-like atom of atomic number 4 in order to excite the electron from state this. The energy required is. An electron revolve around the nucleus of a hydrogen-like atom of atomic number 4. Z is 4. Okay. In order to excite the electron from, okay, the formula is very simple. Delta E will be minus 13.6 into, this is the energy of the electron. Okay, acha, but they are asking for the overall energy. Acha, energy required. So 13.6 into 1 by 2 square minus 1 by 3 square into Z square. Now this is simple. 13.6 into 3 is a 9 minus 4 is 5 upon 36 into 16. Now you solve it and definitely you will get the answer 13.2 electron volts. Got it? Now the momentum of the, see what is momentum? P is equals to H by lambda. What is lambda? Lambda is, see we know that C is equals to frequency into lambda. What is lambda? C by frequency. So it is C by H nu. What is H nu? H nu is energy. Energy upon C. So what is the formula for momentum? Energy upon C. What is energy? Energy, we can say energy is 13.6 into 1 by 1 square minus 1 by 3 square electron volts. So we need to convert it into joules also, upon 3 into 10 to the power 8 meter per second. So this is how you will get the right answer. Okay, clear. Angular momentum of electron in hydrogen atom is proportional to, see, angular momentum is mvr is equals to nh upon 2 pi. Okay, the angular momentum of an electron in hydrogen atom is proportional to, so from here you can say this is angular momentum mvr. So angular momentum is capital L. this is equals to nh upon 2 pi. So it is technically directly proportional to n. Now does n have any relationship with r? You will say yes, sir. R is equals to 0.529 into n square by z angstrom. So technically R is directly proportional to n square, or n is directly proportional to root r. So angular momentum is directly proportional to root r. This is how they are looking to solve this question. Question number 44. An hydrogen atom in its ground state absorbs 10.2 electron volts. Okay, if it is absorbing 10.2 electron volts, okay, then its angular momentum is increased by, okay, see, we know this gap when you are in the first state, then what is the energy here? Minus 13.6 electron volts. And what is the energy here? It is 3 point minus 3.4 electron volts. So what is the energy required to transfer an electron from this to this state? You will say, sir, it is exactly 10.2 electron volts. That means if initially angular momentum was L1 was h upon 2 pi, so now it is 2h upon 2 pi. And what is the difference? H upon 2 pi only. Put the values, get your answer. Okay, so students, in order to attempt this question, what we will do, we will say that here the formula is n1 by n2, and there's a formula, it is equal to sine to the power 4 theta 2 by 2 upon sine to the power 4 theta 1 by 2. So it is going to be sine to the power 4 45 degrees upon sine to the power 4 30 degrees. Now you put the values and get your answer. Okay, is it clear? Now let's move ahead, and question number 46, again same. So what is the binding energy per nucleon? Very simple. First of all, find out the binding energy. It will be total number of neutrons, that is 35 minus 17 into mass of neutron plus 17 into mass of proton minus mass of the chlorine nucleus into, this is all in terms of atomic mass units, into 931 mega electron volts. Okay, so you just have to put the values and get your answer. This is binding energy, but they're not asking binding energy, they're asking binding energy per nucleon. That means whatever the answer comes from here, divided by 35 in order to get your correct answer. So this will be your correct answer. So it's a lot of calculation here, no doubt, but you have to go through it and get your answer, and it comes out to be 8.2 mega electron volts. This is amazing. See, whenever x a z undergoes an alpha transition, it becomes y a minus 4 z minus 2, right? And whenever it goes through beta negative transition, it remains a but z plus 1. Okay, one electron goes out. And whenever it shows beta positive transition, it remains a and z minus 1 plus 1 positron comes out. Okay, remember these things. Now we are gonna go perfectly here. See, so z is 92 initially, 92. So we will like write like this. So 92 initially alpha particle, that means minus 4. Sorry, z na minus 2. Alpha particle z minus 2. Then beta negative particle plus 1. One more beta negative particle plus 1. Now 1, 2, 3, 4, 5 alpha particles. So 5 times minus 2. Then beta negative, again beta negative, plus 1 plus 1. Then again alpha minus 2. Then beta positive minus 1 minus 1. Then again alpha minus 2. Now can you do this? Just do this calculation, your answer will come out to be 78. Got it? 92 minus 2, that is 90, plus 2, 92 again, minus 10, 82, 82 plus 2, 82 plus 2, 84, 8 minus 2, 82, minus 1, 81, 80, minus 2, 78. So what is the final answer? 78. Got it? Like this we will function. Since this is alpha decay, this is beta negative decay, this is beta positive decay. Z minus 2, Z plus 1, Z minus 1 happens. Okay? Now, during mean life, so mean life means T equals to 1 by lambda, right? This is average life or mean life, right? The fraction that disintegrates is C. N is equals to N naught e to the power minus lambda T. So N is equals to, in one mean life, so this is remaining amount. Disintegrated amount is this. Got it? Question number 41. This is an interesting question. See, here this is being pulled up and it is pulling this 1, 2, 3 and 4 blocks together. So let's say if this is M, this is 4M. So this one is gonna pull the mass 4M with an upward acceleration A and tension is T, suppose. Downward is 4 mg. So what will you say? T minus 4 mg is equals to 4m into A. So what is the tension? 4m into G plus A. Put the values, get your answer. Okay? 4m into G plus A. G is given 9.8. Okay, put the values. A is given 2.5. Put your values. Answer will be 4.92. Clear? Because the tension between first ring and second ring is responsible for pulling up all these 4 rings together. Got it? Now the next one is, okay, so there's a formula, students, and what is that formula? This answer is wrong. Third option is correct. The formula is the thrust force is equals to relative speed, okay, into dm by dt, or we say the rate of burning of fuel, right? And they're saying that the rocket should just lift up. That means the thrust force must be equal to weight of the rocket, right? So what is M? 1000 kg. G is to be taken 10. VR is how much? 100 into mu. So you tell me what is mu? It is 100 kg per second. Okay, students, so I hope that this solution series, this solution of the paper has helped you a lot in order to understand the different topics in physics, right? So kindly do this paper as I have told you. Try the question on your own, then watch my solution, then match your solutions, and if you are not able to solve it, then try to learn from it, right? This is the way you need to proceed, and you have to analyze every question. This is how you're gonna, what do you say, empower yourself for the examination, right? That's all for today. Thank you so much, students. Please subscribe to our channel, because you subscribe, we survive. Thank you so much.